The mic is not working. I'll repeat. So this a new video, everyday video I code until I find a job. So welcome everyone. Hope you're doing okay. So today we're gonna solve, like any other video, like any other day, we're gonna solve some lead code problems. Those lead code problems are devised by themes. Today we're gonna solve some lead code problems that are focused on fantasy world and magical abilities. So the first lead code problem that we're going to focus on is climbing stairs. As usual, you can find me on GitHub, LinkedIn, and Instagram. My social links are in the bio of YouTube. I think the sound is cool. So we're gonna solve this. Let's go. Let's draw a little bit. So, okay. I think I can. That's cool. So on this problem, you're climbing staircase. It takes n steps to reach the top. Each time, you can either climb 1 or 2 steps. In how many distinct ways can you climb to the top? Example n equal to. So I have. It takes two steps to reach the top. There are 2 ways to climb to the top. 1 plus 1 step or 2 step. 3, 1 plus 2, 2 plus 1. Each time you can either climb 1 or 2 steps. Okay. So let's say I have n equal 4. So each time you can either climb, so I can climb 1 step, so 1 on 1, or 1 to 1, 1 to 1, or 2 1 1, or 1 1 2, or 2 2. I think that's all. So every integer are divided by 1 or 2 steps. It's a loop, I think. We can mark it by loop or recursive. So if it's 2, then 1 1 and 2. So the first combination will be composed by sum of 1 n equal 4. So this is the first combination, always. Let's just so n range n just print 1. So this is the first, and the last, it's a division by 2. If the number is pair, so we just have to iterate through n by 2. So let's think again. Today I'm going to solve 2 or maybe 3 problems. I just want the video to be 1 hour long. If we have enough time, we're gonna solve 3, but if we don't have, so we're just gonna solve the others tomorrow. So if the number is pair, so this is pair, modulus 2 equal 0, then first combination we're going to be sum of 1, the second, which is the rest, will be sum of 2, but n divided by 2. The third is combination of 1 and 2. But how we do this? Suppose it's 4. So 4 it's 1, 1, 2, 2, 1, 1, and 1, 2, 1. Cannot be anything else. 5 it's 1, 1, 1, 2. This is not fair. So let's go 6. 6 it's 1, 1, 1, 1, 1, 2. And we just, this can be this can be, I just want, so this, there is 1, this 2, this combination is 3, and this has a combination of 1, 2, 3, 4, 5. This is 5, and it can be also 2, 2, 2, 2, 2, 1, 1, and this can be 4 times. Yes, it can. 4 times, and then 2, 2. So this is 5 and this is 4. It's like the so 5, 4. So this has 3 combination and 1 combination, and this 4 combination. This can be repeated only 1 time. Always this 1 time. This is the number of the integer itself, so n plus 1. Here and here 3, which just to be n minus 1. So n minus 1 plus 1 plus 4. No, n. 2n. 2n. Select all this. 2n. 6 has 2. Just swap those. 2, 1, 1, 2. So I switch that, then I switch that. 1, 2, 1, 2, 1, 1, 2, 2. Is there a 1, 2, 3, 4, 5? It's 5. It's the same. Oh. 5. So this is n minus 1. So it's 9 minus 1, 2. I think it's recursive. We can to make all the combination. How about we just so 2. Just erase all this. So we have sum of 1, sum of 2, if it's pair. This is sum of 1, sum of 2, if it's 4. So 1, 1, no, 2, and 1, 2, 1, and 2, 1, 1. So here we have 3 combination, which is n minus 1. Let's say it's 6. So 1, 1, 1. You can go to 4 and then 2, and here we can switch this 5 times. Switch that 5 times, so which is n minus 1. And if it's 1, 1, 2, 2. Here we can switch it 1, 2, 1, 2, 2 here, 2, 1, 1, 2, so 3. So it's 5 again. So every number have n minus 1 combination beside the sum of 2 and sum of 1. So we just have to n minus 1 plus plus 1 plus 1, which is this for sum of 1 and this for sum of 2. So logically it's n plus 1. 2 doesn't have. Well, if it's 3, let's say 3. Now we have not pair. So 3 only have sum of 1 and 1, 2 and 1, 2, 2, 1. So here is a combination, here is a combination. So I have to consider it as, so 3 n minus 1 and then 5. Yeah, so 3 here, 2 here, so 3. Let's say 5. 5 it's 1, 1, 1, 2, and this we can switch it 4 times. I think 4. 1, 2, 3. 3 beside that, 4. Okay, so it will be for integer which is not divided by 0 will be 1 plus 1 plus n minus 1, which is n, and for that will be n plus 1 beside the v2, because 2 it's only have 1 plus 1 and the pair. The pair problem, class solution. Previous answer in chat. I didn't understand the welcome to chat. Welcome everyone. Didn't end previous one. I just want to solve it myself. Thank you for the answers. I think I got it. So just if the number, if it's 1, so it only has 1. If it's 2, it only has 2. And if it's greater than 2 and divided by 2, then we're just gonna return the number itself. No problem. Thank you everyone, thank you. So if n equal, then we're gonna return 1. Well, we can consider it as an even number. So let's just write the whole answer. So if n is not divided, or it's divided by 2, so we're gonna return n plus 1. And if it's not, so we're just gonna return the number itself. N plus 1. So here, except 2 and so just return 2. If it's 2. 6. Else return n. I think this is correct. If it's 1, so it's gonna return 1. So just submit it. 5. n equal 5. Return 8. What is 5? Return 8. So it has 4. Oh. It has also the 2, 2, 1. And there we can switch it 3 times, so 3 plus 4 plus 1. Okay. Batman does sleep. No, we're not sleeping today. Tomorrow sleep. Today we have work all day long, so all night long. So 3 plus 4 plus 1. It's sum of n. So 5. think the odd number is correct. Just focus on the even, on the odd. Let's say we have 7. So 7, it's sum of 1, which is 1, and 1, 1 until 5, and then 2. And this we can switch it 6 times, and 1, 1, 1. So this until 5, until 3 and 2 twos. And this we can switch it 1, 2, 3, also 6 times. Then 1, 2, 2, and 2. This we can switch it 4 times. No, here 5 times. 4, 5, 6, 1. So there is no 3. I bet there's 3. So I think he's gonna sum the 3 4 plus 3 plus 2. No, he's gonna sum 3 last number. And that should be easy. If it's 9, so 1, 2, 7, and then 2, and that we can switch it 8 times, and then 1, 2, 2, 5, and then 2, 2, and then we can switch it 7. So it's sum of let's just look a little bit. I don't wanna do this anymore. To me. 1904. Promise tomorrow. So minus 1 and minus 2. But here also we have also 4. And so but 7, so he's gonna, and 3, do we have 3 in 7? 3 combination of oh yeah, we have 3 combination, 1, 2, and 3. Oh, so 3. Then we have 1. So this is 3, this is 4, and this is 5. So which is n minus 2, then n minus 4, this n minus 3. So every time he's gonna think if n equal. just a chat if n equals 0, then you're just gonna return 0, or n equal 1, so you're just gonna return n itself. Else you're just gonna return the same it's recursive, same function, but this with n minus 1, and we're gonna plus n minus 2. I think that should be easy. Oh, return. It's not defined. Global. I'm just reversing it. I have to put self or fuck. It's not defined. N minus 1 or n minus 2. Why the recursive is not recursive function Python? Yo chat, everyone is good. It's not a great thing yet. For a while. Oh, what? Recharge here. So basically this is my same. I'm thinking something on scope. Oh, self. I just read self. Yeah, I thought of it. What? Not button. N minus 2 and n minus 1. Oh, return 1. But if n is 0, so it's not gonna do it. N minus 2. If the world is ending, I wanna be next to you. So first problem in 30 minutes. That's low, honestly. That's easy one. Limit exceeded. Yeah. Let's try just copy it. It's work. Do I have to code it in Java? Let's write to code in Java. So the world is ending. So if n equal 1 or n equal 0, then we just have to return 1. Else we return the same function but just with n-1 plus n-2. In fact, I'm gonna just see the solution, but they really suck. In Java. So this is faster than the so dv equal to 0. So it's gonna create a list of 0 that has its size n+1, and then he's just gonna make the first index equal 1 and the second index equal 2 for a range 2 n+1 deep to e this one. Oh, he's gonna fill it with ones. No, I really don't get it. What's one? Sure, because they're only one to clamp 0 and 1. Oh, there is from 2 to n inclusive. For each step in the number of ways to reach the step is the sum of the number which reach one step. If we climb, so he's gonna sum it. So here in the index equal 2, the value will be 2. So 1 1 2. If it's 3. Then he's gonna sum it. I see. Clever one. It's really clever, but I think the recursion is better, but it's just a matter of time. Yeah. So let's go with the other problem. It's unique paths. So we're gonna discover all the magical paths to reach a wizard castle. So let's go. Unique path for all of it. There's a robot on we're gonna work with matrix. The robot is initially located at the top left corner, grid 00. The robot tries to move to the bottom right corner, grid m-1, n-1. The robot can only move either down or right at any point in time. Given the two integer m and n, return the number of possible unique paths the route can take to reach the bottom right corner. In this case, are generated so that will be less than equal to input m equal 3 and n equal set. You can add unique. So let's say let's erase all that. Let's say we have a matrix of 3, 2. So have it's not the matrix. Oops. So 3 and 2. So the robot is here and he's gonna make it to here. So we have this path 1, this path 2, and this and we have this 3. He can go like that. It's 4. 3, 2. All the best, bro. You could know. Thank you. Welcome to stream, man. Let's try another matrix. Let's say 2 and 3s. 2 and 3s. Have this robot and this. So I can this 1, this 2, this 4, and this is right, and this. No. So I have 4 unique ways. From top left there is total of 3 way. Reach the bottom right corner. That's 4 actually. Even if you spin it, so it's a matrix of. I just want to spin it. So this matrix of 3, 2. It's 4 possible way. How he say 3? Let's suppose it's 2, 2. So we have a matrix of 2, 2. And we have our robot and 1 and 2. So here we have 2. But if it's 3, 2, if it's 4, 4, let's say it's 4, 1, 2, 3, 4, 1, 2, 3, 4. So he's right here in the top left, and he's gone here. So he can like that, like this 2, and he can go like this, and also this. It's 4. Cannot make it like that. Think combinatorics, you can only move down or right each time, so try doing both at each interval. Okay. You're overcomplicating things. Yeah, I think, yeah. Welcome to stream. I worked on this problem last year with the semaphores problem, if you know the term in Java. It was a really good problem, but here I'm not sure what to do about. I want just to draw it. I'm just will draw a matrix of 1s and 0. 1 is the way that the robot is going to go. So here we have, so let's 1, 1, 1, 1 and 1. So that's a way. Let's just okay. Bleh. Let's move it around. 1, 1, 1, 1 and 1. So this is another one. Let's say 1 here, 1 here, 1 here and 1 here. This is another way. Then we're gonna reverse 1, 1 and 1. Another one. And then 1, 1, 1. I can go like this. So we're gonna 1, 1, 1 and 1. That's another path. I think this one is not going to work. He can go like that. He can go like that and this. Oh man. That must be another solution. This approach doesn't. Those don't. Mm-hmm. So this is it. So it will be a recursive function of fun. So every time he I see. Don't dimension of 1, 2, 3 and length 2. So I have the I want the combination of of a matrix of ones and zeros. Let's try it out. But I want the one to be right here. So I want the matrix to look like this. Here we have a 1, here we have a 1. The first step, we initialize it like this, and then it will be ones on the diagonal and on this way. So we want a combination of matrix that starts with 1 here and 1 here, and he's just gonna then iterate it. Is there a combination matrix? Jag vet inte ens göra att jag måste komma nog kanske. the solution. I can only move down and right. Oh, oh, down or right. I cannot move up. And I think this is the case. So it's a matrix of. Ah, I now understand why. So here we have A3. You can only go down and right. So right, down, down, or down, down, and right. Oh, or down, right, down. So equal 3. Fits 2 by 2. So you cannot, you can only down, right, or right, down. So 2. If it's 4 by 2. So down, 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 right, 1, right, down, 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 right, down, down, 3, right, down, down, 1, 2, 3, 1, 2, and 3, 3. It's because the robot can but the cell must come from one of these two adjacent cell. Recursive solution following this approach would involve a lot of repeated calculations, so been approached to use an iterative DP algorithm which build the solution bottom up and avoid recomputation. Specify we can track the number of ways to reach each cell in single row as we iterate across the grid. We initialize a list F with a length of n, number of columns, and set all values I, 1. Because there is one way to reach any cell, then just implement the dynamic program, which is an algorithm technique to use solve break them down some problems, So we're gonna create an array that has a number of columns multiplied by 1. So this is the first path. We iterate each traditional row in the grid starting from the second row. So the first row is already initialized. The number of unique paths to each cell in the grid position EG equal the sum of path EG minus 1. And E minus 1G. So for range 1M, for G range 1N, FG equal FG plus FG minus 1. Path counts, and then for row, and then for range, path calls equal path calls minus 1.
These are the 8 most important patterns for coding interviews, and this is backed by data.
No, this is irrelevant. So the first replaced entry have gone through all the rows. As a result, you accumulate num in the list cell. This algorithm is and the type complexity M multiplied by 2. Because you have 2 loops. So I'm gonna initialize f equal once n. Then I'm gonna for in range we're just gonna 1m goes unique path. Gonna recurse of it or path count. F of course f of G plus equal f of n minus 1. That's right. Then return f. I'll just return see what others. 2 pointers. So the approach with formula combination Sm plus 1 minus 2. A set of calculating factors directly, which may cause overflow, calculator result, reduce computation, iterate through time complexity, size complexity. So he's gonna make the first part and the second part, and a double, which is one for you. That's a clever one. So I think here we're good. So today we solved two problems. I hope tomorrow we're gonna solve other two problems, or maybe three. Thank you all for watching. Thank you for the support. Thank you for subscribing, and see you tomorrow.